Hello, seventh hour computer science. We're going to go over your activities that you're going to do for the day. The substitute teacher should play this video and stop it about every minute and make sure that everyone is where they're supposed to be. I expect you guys to work together. If you and your partner aren't having any trouble assembling your stuff, your the stuff from your microbit box, or having any problems with the code, but your neighboring team is, once you get done, with yours, uh, you may help someone else. So let's go on, and we are going to look at the flex sensor. So we did inputs to a pressure sensor. In that assignment, what we did was you built your analog value code, and you'll need that again, so we'll open that up. Like I said the other day, this all works the best if one partner opens up the MakeCode site and the other partner opens up Google Classroom to follow along. And the person that works on the MakeCode is also the person that does most of the assembly of the box components for that particular activity. And then each day, then have the other person do the opposite thing so that everybody gets a chance. So I'm going to go ahead and I'm going to open up the flex sensor paper. It's not nearly as long as the one that was the pressure sensor. So the very first thing that we're going to do is we're going to look down at the questions. Then we're going to come up to the top and we're going to assemble our stuff. And then we're going to get the readings that we need. So the questions that you need to answer: number one, analog or digital. So do you remember what the pressure sensor was? Because if you can get a range of values, which one of these does it have to be? Because the flex sensor and the photocell resistor and the pressure sensor are all the same. They measure a range. That's why when you bend or push or cover, you get a change in number, because we can have a various bunch of codes. The next thing, what are you measuring with the flex sensor? You've kind of already answered that when you did inputs 1. Go take a look at it if you're not sure. The next question is, what is the measurement, the number that you get when you bend the flex sensor one direction? Question number 4 is, what about when you bend it the opposite direction? And the last one is, you're going to go ahead and bend it, or you're going to not bend it. You're just going to let it lay flat and see what kind of a reading you get. If you scroll down, the next thing it says, you're going to build a code so that if the value is greater than 550, we should have a happy emoji. If the value is between 450 and 550, display an X on the microbit. If the value is lower than 450, then we're going to display an unhappy emoji. Okay, so I'm going to switch over to my presenter, and I'm going to max this out so you guys have a better way of seeing it. What you're going to need for this, out of your box, you're going to need your yellow cable, your yellow alligator clip. You're going to need your red alligator clip. You're going to need 2 boy-girl connectors. So you want the point on one side, no point on the other. Oh, there he is. So I have my two there. You're going to need your microbit. You're going to need your USB cable. And you're going to need your flex sensor. Looks like this on the end. All right. And I'm going to move my box aside. That should be everything that I need for this assignment. First thing I'm going to do and handle, because a lot of kids are like, why can't I get this to send? They don't plug in the microbit. So the very first thing you're going to do when you have all your equipment, let me put it out again. So yellow alligator clip, red alligator clip, 2 connectors, boy on one side, girl on the other, your USB, your microbit, and your flex sensor. I'm going to have the substitute stop the video right now just for a second to make sure that everybody's got what they need out. Okay, so I'm going to take my microbit first of all. I'm going to plug in the small side of the USB cable into my microbit. I'm going to plug in the USB to my computer. It's showing the old code from earlier. I'm going to use my yellow clip, and I'm always going to clip that to pin 0. I'm going to take my red clip, one side of it anyway, and I'm going to put that to 3V. Oop, unsnap there for me. Now I'm going to go ahead and I'm going to have the pincher, the red, click the boy side of one of my connectors, and the yellow, click the boy side of the other connector. We'll connect the flex sensor in just a minute. We'll get back to that. So, substitute, I want you to go ahead and stop the video a second and make sure that everyone has their microbit and their components all assembled this way. USB to computer to microbit, yellow pin or yellow alligator clip off pin 0. Red alligator clip off pin 3V, and both of those alligator clips connect to the boy part of boy-girl connectors, and our flex sensor is still sitting out. So we'll stop now. Okay. The first thing we have to do is we have to get a reading from our flex sensor. So we already built this code. You shouldn't have to do this again. So I'm going to go to a tab. I'm going to open up Make Code Microbit. And my analog value code is showing. But if yours isn't, let me show you how to go get it. If you go to Import and you go to Import File, choose File, your stuff should have gone into Downloads. And then open up your analog value. You'll find it probably in your downloads. For you, for 7th hour, it should be analog value 7. And then hit go ahead when you after you click it, and it will open up that code. Remember, what this is saying to us is forever, I want to set the value that the analog component that I have plugged in to pin 0, I want to show that value. That's what this is saying. So I'm going to go ahead and I'm going to download this code again. I'm going to click on the caret. If it says something about, do you want to overwrite another copy of this file? That's fine, not a problem. Click on the caret that's pointing up. Go to Show in Folder. Remember to right click, Send to, and microbit. Now you'll notice that the microbit is blinking. When it's done blinking, it's got the code. It went away. There we go. Let me max this out. And now, right now, it's trying to get a reading. Mine must be crazy. It's already got a reading, and we haven't even done anything yet. So what now we're going to do is we are going to assemble the flex sensor along with the rest of the stuff. So on the girl parts of your connectors, you'll see 2 silver parts, 2 silver sides of those squares. This usually tends to work better if you face them toward each other when you're connecting a different component. Now, one of the reasons you have partners in this class is because it's kind of difficult sometimes to do everything that you need to do, like hold it and bend it and do whatever else. So I'm going to put then the little, yes, this is way more fun than you can possibly imagine. So I don't know why I'm having a problem. Here we go. So I finally have my flex sensor connected both ways. And the first thing it says is if I bend my flex sensor one way, what is the measurement? Now remember, you can't fold it, you can only bend it. So we're going to go ahead and bend it. And my reading says 994. Now, if you'll notice, not every reading is going to be the same every time, but 994 is what I have if I bend it one way. On the paper sheet that you're supposed to be completing the answers, why don't you go ahead and write 994 for bent one way? Let's go ahead and we're going to bend it the other way. My reading there is 313. That's quite a bit of difference. So maybe one is more, you know, shows more of a change than the other. So I might write down 314. They really should be pretty close to each other, but they're not. That's okay. The last thing it says is if I were to lay my flex sensor flat, what would my reading be? Interestingly enough, if I lay it flat, my reading is 333. That's probably accurate. The second one probably isn't, but that's okay. I want you to fill in whatever answer you get. Remember, these components are at a school. They're not super high tech. They're just to see, they're just to show you how some of this stuff works in real life. All right, so you've done that part. I'm going to go ahead and have the teacher stop the video now and go around and make sure that everybody has an answer for the questions about the readings for bent one way, bent the other way, and straight. So substitute, you may go ahead and stop now, or stop the video now. Okay, I'm going to go ahead and I'm going to create the code that they want us to complete that says we would have a, let's see, was it a smiley face? Got to find it. Okay, if we would have a happy emoji, if we would have um, an X, or an unhappy emoji. So I'm going to go to microbit right here. I'm going to go to new project, and I'm going to call this flex sensor. Oop, forgot a letter, didn't I? Oops. And since I'm doing this with you guys, I'm going to call it flex sensor 7, and I'm going to go to create. I'm going to lay I know my flex sensor is going to come unhooked. That makes me sad though. So what we're going to do, we're going to go ahead and build this code. So the first thing that we're going to do is we're going to get rid of the on start, and I'm going to delete that block, and I'm going to go into our assignment, whoopsie, for the flex sensor, and I'm going to look at this. If the value is greater than 550, happy emoji. Between 450 and 550, X. If it's lower than 450, display unhappy. So I'm going to scroll down and see what that looks like. So I'm going to need 2 LEDs, an if, else if, or an else. I'm going to need 2 greater thans. I'm going to need 2 analog read pins, and then I'll have to have those numbers that they gave us. And you'll need a show icon. So let's go back up to this. And the first thing I'm going to do is I'm going to go to logic, and I'm going to pull out the if, and we're going to go to else, and that changed to else if. The middle one does once we put that in there. I'm going to look back at that code again. I need 2 LEDs and an icon, so I'm going to go ahead and I'm going to pull out 1 LED. I'm going to duplicate it, and then I'm going to bring out a show icon. My icon is going to be the X. I know that already, so I'm going to put that here. I'm going to put 1 LEDs here and 1 LED there. And this should be happy. And I don't care if it's the exact happy that they're showing or not. I just care that it's happy, or if it's sad. Here we go. So I got to be able to tell the difference. I think I'm going to have to move his nose. There we go. So we got happy and sad. Now I'm going to need those greater than, less than blocks. And I said I needed 2 of those. So I'm just going to go ahead and pull 1 out, and I'm going to duplicate it. I'm going to make this one, if it's greater than, I'm going to make this one if it's less than. And I'm going to put this one up here, and I'm going to put this one there, because we wanted the greatest one to go with the happy, and we wanted the less than one to go with the sad. Greater than, the number they gave you was 550. The number, if it's lower than, they chose below 450. Okay. We don't have to put a number here because we know if it's above 550 and below, if it's not above 550 and it's not below 450, then it's got to be in between the two, right? Makes sense? The last thing we need is our pins. So if you always plug into 0, you never have anything to worry about. So go ahead and scroll down to your pins. You're going to need analog read pin 0. And you're going to need 2 of those. And I'm going to duplicate. And I'm going to put that there. All right. All right. The last thing that we have to do here is we have to download our code. So I'm going to go ahead and download it. I've turned this, okay, and I'm going to go to, I want that to be in PL, I'm going to put that in download so it's just like yours. I'm going to go to save. I'm going to try to turn that so it doesn't show again. Drive me nuts. So if you remember how to send it to your microbit, click on the caret up, go to show in folder. Here it is, Microbit Flex Sensor 7, and I'm going to go ahead and right-click that, send to Microbit. Once again, your microbit should be lighting up, and you should be able to see it real good. You see the back. So let me go back to our view here. Oh, I just did the wrong one. Here we go. Okay. So right now, it says, if you look at my thing, it's Mr. Happy Face. So I must be getting a reading above 500. I am not even doing anything. This flex sensor might be a little squirrely. So if it says it's below 450, then it should change to a non-smiley face. But yeah, that's not happening. Mine is evidently going to act foolish. But if I undo my flex sensor, I did get the sad face. Well, he's blinking back and forth like a madman now. I'm going to plug my flex sensor back in. And I'm going to try this again. So I'm going to bend it. Yeah, it is. Yeah, you can see that my equipment isn't necessarily working fantastically. So, but right now it says the bend is above 550. If I bring it back, maybe if I bend it the other way, but I'm not seeing it. So basically what really should happen is that the more you bend this, we should see the happy face, and the less it's bent, we should see an X, and then when it gets to the least amount, we should see a sad face. If yours did that, then it's correct. At this point, you may go ahead and complete the rest of the questions. What are you measuring? Is it digital or analog? And then make sure that you have this code ready so that when I return on Monday, well, for you guys, Wednesday, that I can check over it. When you finish, you may go ahead and turn the worksheet in on Google Classroom.